What's going on, everybody? Jesse here, and welcome back to another episode in the Blueprints to C++ tutorials. In this one, we're going to take our player character movements and we're going to move them from our blueprints and throw them into C++. So sit back, relax, and enjoy. Today's episode and others just like it are brought to you by the patrons listed on the screen. If you'd like to support the channel and future development, then consider visiting my Patreon or Buy Me a Coffee page, where you can receive various benefits such as early access to my videos, project downloads, as well as personalized support. You may also want to consider joining the community by joining my Discord server, where you can receive help from me as well as the community. So come on over and be a part of the conversation. All right, so currently in our blueprint project, we have our player movement on the player controller. I'm going to take this and we're going to put this into the player character, but we'll use this as reference of how we're going to move this code into C++. So we currently have 3 movements in here. We got a couple other input actions that we're going to have to take care of, but we're also going to need to create a function for this adding the mapping context. So let's go ahead and create a new C++ class. So come down here into C++ class and choose your project folder there, and then right click and new C++ class. We're going to add a character. So we're going to come back. We're going to base our current character off of our C++ class. We're going to reparent it. So select the character, hit next. Go ahead and give it a name. I'm just going to call this primary character, and make sure over here in the runtime, make sure we have our actual project. If you want to include the character in your inventory system plugin, then go for it. I recommend not doing that. It'll just make your plugin that much bigger, and your character probably isn't going to be applicable for every game that you want to put the inventory system in. So I suggest not doing that. So we're not going to do that in this video. So make sure you have your primary runtime project selected, and I'm going to put this in a different folder. Remember, it's important to try to have your folder structures set up when you're creating your files. It's just going to be a whole lot easier for you if you can have a good organizational structure to begin with. I'm going to add a folder here. So in the path at the very end of this, I'm just going to type in the name of my new folder, and I'm just going to call this character, and you can see it already added it here. Put the character here, and it's going to create these 2 files for me. Create class. All right, once it's done, it should end up loading your IDE. If it doesn't, go ahead and open it up. But once it opens, you're going to see we're going to instantly get errors. This is going to be a common theme when you're creating new C++ classes that aren't in the primary source folder structure. So all you need to do is come up here, expand your include file. This is on the .cpp, and then all we need to do is remove the folder structure that we added. So we added the new character folder. We don't need that here, so just go ahead and backspace it, and there you go. But with this actually fails the build. So you probably got this pop up here, says build failed. So that's just because they include. So with that, go ahead and close that down. Once we fix that, go ahead, we can build it now. Make sure you build it after this. Otherwise, it's not going to show in your editor. And there we go. We successfully linked the patch there. So go ahead and close down the live coding window. And before we do anything here, let's go ahead and reparent our character to this new C++ class. So jump back into the editor. All right, back in the editor. I'm going to jump over here to the actual character, and you can see its parent class is character. We can click this and change it here, but just come over here, select the class settings, and parent class, it says character. Go ahead and drop this down, and then just start to type in the name of the class that you just created. So it's going to be a C++ class. And whenever you see it in italics here, this is going to be a C++ class. If it's not in italicized, if it's not leaning sideways, then it's not a C++ class. So select that, and you should not have any issues. We haven't done anything yet to the C++ class, so it should just be a nice smooth transfer. Just go ahead and compile it, make sure that everything is good, shouldn't have a problem. So let's go ahead now, and we still have all this code in here. We're eventually going to take all this and put it into the player, but today we're just going to do the player movement. So let's jump back into the player controller. All right, so we have to have a way to communicate. Communicating from blueprints into C++ is the most difficult part of communication when you're working between the two systems. It's easy to go from C++ to Blueprints, but working the other way around is a little bit difficult. So I'm going to show you an easy way to kind of work around that. It's not going to work in every instance, but it's going to work here for our player controller. So we've got these three functions here. Let's go ahead and make sure you save everything here, and then I'm going to jump over into the IDE. So I'm now in the new primary character.h in the header file here. I went ahead, it comes with some default comments in here. Whenever you start a new class, I usually go in and just delete those comments. And you also know here, it kind of throws things out of whack a little bit, right? We got a public section here for our constructor. Then we got a protected for our begin play. Then we got another protected section here. It doesn't matter. You can do this as much as you want to, but I'm going to go ahead and organize this a little bit. I'm going to take what here in the public, and I'm just going to take it and move it up here into this other public section. And now with that done, we're going to go ahead and do a little bit more organizing. Now, what I like to do in my header files is I like to have two different sections, one for all my properties and another section for all my functions. It just kind of makes it a little bit easier when you start getting a whole bunch going on into a single class. So what I do is I just create some white space in here. Now, anytime you're right below your generated body, if you don't have any classification here, public, protected, or private, this is automatically private in here. So you don't have to type anything, or whatever you type here is going to be private if that's what you want. So just keep that in mind. Usually when I'm organizing these though, I try to have my public, protected, and private in that order, just kind of ascending in that direction. So with this, I'm going to go ahead and create some new functions or some new properties. All right, so I'm going to come out here with the first one. We're going to actually make this, even though this is private in here, this will eventually be moved down once we get some public properties in here, but I'm going to type private, get it in here. Now on my screen, you see it graded out. Whenever you see gray like that in this instance, it means that it's useless. It can be removed. So I don't necessarily need to have that there, but I'm going to, because like I said, I will have some public and protected above that. So a little bit of space in here. So our first one, we're going to go U input action. We're going to make it a pointer. I'm going to call this first one jump action equals null pointer. Okay, so with that, I've got the red sign in here, means we need to include the file. All right, so I'm just going to come up here to make sure anytime you add and include in your header, make sure that generated.h is always the last header in there. It must be the last, or you're going to get build errors. So I'm going to go include input action.h, and there we go. Now we don't have that in there any longer. Don't worry about this yellow squiggly line. We'll take care of that in a second. Create our second one, U input action pointer. I'm going to call this one move action, and I'm going to initialize it as a null pointer. U input action, look action, null pointer, input action pointer, interact action equals null pointer. Now we're not going to do anything with this right away, but I want to go ahead and just get this in here. And then the next one we'll do is another U input action pointer toggle inventory action. And again, we're not going to do anything with this right away, but we'll put it here just so we can create some bindings. And then lastly, we need to go a T object pointer PTR, and in the brackets here, we're going to go U input mapping context. So this will be so we can add the mapping context to our character, so that way we can actually use the input mapping actions. I'm going to call this one input mapping context equals null pointer. So we initialized all this as a null pointer here just because we want to make sure that when the game starts, there's nothing in here with these. Now what we're doing with these is we're creating these, even though they're private, we're going to get into blueprints and we're going to set these input actions there. So this allows us, this is how we're going to communicate from blueprints into C++, is now we're going to have this variable here in blueprints. We'll fill this with the correct input action that we want, and then in C++, by just calling this variable, we will now have access to that input action. In this case, it will be the input action. So, but this won't, we're in private right here. We won't be able to see these in blueprints right away. We need to make these, the reason why we got the squiggly line there, the yellow, is because we need to add the U property. So U property, edit defaults only. I'm going to go blueprint read only. I'm going to give it a category equal to character input. And if you put the pipe symbol in here, that's going to create a subcategory. So character input will be the primary category. Then it'll have a subcategory. I'm going to call this character movement. I'm going to come out of the category, add a comma, go meta equals. Now this is the important one. Allow private access. So we won't be able to see these in blueprints because they're private. So we need to give the meta allow private access. And I added an extra bracket here that we don't need. And there we go. So now what I'm going to do is I'm going to copy this entire line, and I'm going to go ahead and give the same U property to the other input actions. So you notice here with the T object pointer, we got the U input mapping context. It's in red. We're still getting an error here. So we need to actually forward declare this. We're not going to include this here because this is a relatively big file, but we're going to call this in our source file, in the CPP file. So we need to forward declare it here so we don't get this error. So when it comes to the T object pointer, if you watched my fundamentals, you'll know that we can forward declare in line. We can put class here, but when it comes to this T object pointer, we can't put the class in front like you see right here, because it thinks you're trying to forward declare T object pointer. If you want to do it in line, you come in here inside the brackets and you type class. I don't like doing any of the classes in line, if you saw that in my fundamentals. So I'm going to come up here below the include files. I'm going to go class U input mapping context and then give it a semicolon to close it out. So there we got rid of the error right there. And before we jump into the source, I'm going to come down here and I'm going to create a new function. I'm going to make it a public function. It's going to be void, and we're going to call it set player mapping context. It's going to be a const input of U input mapping context. We're going to give it, it's going to be a pointer, and we're going to call it mapping context. And with this, I'm going to make this a const function, and we're getting the yellow squiggly because we need to define the function, but we'll do that in just a second here. So now I'm going to come down here into the protected, and let's go ahead and define, or we're going to set out the name of the functions for the movement. I'm going to put in a comment here, player input functions. And then the first one, we will go void move, and it's going to have a const argument of F input action value. It's going to be passed by reference value. Now, if you don't understand what const means you're making a promise to the function, to the compiler, whatever, that within this function, you're not going to change any values, right? So we're going to assign values, things of that nature, but we're not changing anything. So that's what this is for. It's just kind of a promise. So if you're not intending to change a variable or something within the confines of a function, if you make it const and you accidentally change it somewhere in the function, you're going to get an error, and it's going to say, hey, you can't do this because it's const. So it's just kind of a way for you to be able to know that, hey, this is my intention of not changing this. You should try to use this whenever possible. Writer notifies me quite frequently that, you know, with green squiggly lines saying, hey, you can make this const. So that's usually when I just go with it. So we got the move function here. And with this, we're passing by reference. This is just what we have to do when you're passing an F input action value. It's always being passed by reference because it's going to be coming from the engine itself. And the values that are coming in here is going to be of input value. So we don't actually pass anything in here. The engine will through the enhanced input context. Okay. So our next one, we're going to go void look. Again, it's going to be a const F input action value passed by reference. We're going to call it value. Next, we'll go void interact. No, we're not going to pass in any value there. Void toggle inventory. Not going to pass any parameters. And then this one, we're going to actually override a function that is currently in the base player functions. So we're going to go, whenever you're overriding from a parent class, you always have to do virtual void. And the one we're going to override is jump. And then because we're overriding it, we will type the word override, and there we go. So now we're overriding the jump function. So now we're not going to actually really have to do anything for the jump. We're just going to call it. Now we need to go ahead and define this with Writer. I can just go ahead and right click on here. You can right click in Visual Studio and select to give it a definition, quick definition, anything like that. But I have the option. I can go generate definition, and then I can just select all the ones that need definition here and then select OK. And there we go. Now it just threw all these over in the source folder, and I'm just going to go like this really quick. It put everything kind of in order. So I'm going to go and create just a comment here. I'm going to go player input functions. Then I'm going to come down here to the bottom and player input functions. So that way it's just a little bit easier to find if I need to later down the road. Okay, so let's go ahead and set all these up now. So go ahead and scroll up until you see setup player input component. I'm going to go up a little bit further here. We're going to need that. And then here in the constructor too, we'll end up having to call a function here in the primary character. But for now, in the setup player input component, I'm going to give me a little bit of space below the super call. And I'm going to type if enhanced input component pointer. And I'm going to call this enhanced input component. Enhanced input component is what I'm going to call it. If that is equal to cast checked enhanced input component, and we're going to type player input component. Okay. And real quick, what this is doing is we are creating, you can create a local variable within an if statement. So that's what we're doing here. We're creating a local variable, which is of type enhanced input component. It's a pointer. We're calling it enhanced input component, and we're doing a cast check. So essentially this is checking to make sure that this component is equal to this player input component. If we don't have this, we don't want to call the functionality within here. We should have this at this point, but we just want to ensure, and because it's a cast check, it's casting from the enhanced input component to this. The check is just making sure that they're going to be compatible. So with that, I'm just going to go ahead and we need to include this now. Scroll up to the includes and let's go include enhanced input component. And while we're up here, we're going to end up needing one other as well. We'll just do this now, and it's going to be enhanced input subsystems.h. So it's grayed out for me right now because we're not using it yet, but we will end up using it. So go ahead and punch those in here. These are the only ones we're going to need in here for the rest of the day. Scroll back down here. Now within our if block, I'm going to add a comment here, input bindings, and then I'm going to go enhanced input component bind action. And the first action we're going to do is jump action. Now these are the variables that we just created out in the header file. So jump action, it's of input action. You can see there on the screen, comma. Now we need to enter the triggered event, triggered event. Now, if you remember what the input mapping context and input actions all look like, these should look familiar, right? So we have canceled, completed, none, ongoing, started. So when you look at the node, when you're calling these input actions in the blueprint, you're going to have these pins off. So triggered, you'll see that up there a lot. So we're going to do triggered. Here it is right there. That's the primary one we're going to be using. Trigger event triggered. And this needs to be the object. So the object that the function is being called on. So we're going to put the function here. We've already created the function here. So we go this, and then now we need to give it the function name. So our function name is the name of our character here. So where you get this from. So just to show you, I already know what it is, but you can come down here. This is the jump action. So if we come down here to jump, we just take this, copy it. You don't need the parentheses. Come back up here and then paste it in there. Of course, we need the ampersand in front of, and there you go. There's our bind action for our jump action there. We're going to actually do this again here. I'm just going to copy this line and I'm going to paste it in here. So we're doing a jump action again, but except for here, we need to change the triggered to completed. And then we need to change the function here. So instead of the primary character, we have on the main character, we go a character. This is a function that is on the a character, and we can type this here because this is a child of it, but the function itself is on the primary character parent class. And then for this, we're going to go stop jumping. Let's go ahead and finish adding our bindings. So again, I'm going to go enhanced input component, bind action. Let's go move action, triggered event. We're going to do triggered this, and is going to be of a primary character move. Select that and then type in the next one, enhanced input component, bind action, look action, triggered event triggered this, and it won't always be triggered. Remember, it's depending on what your function. Some of these will be changed when we start adding things like our grab functionality, things like that. It will be a little bit different. So with this again, just like we did before, a primary look is what this function is. Enhanced input component, bind action, interact action, triggered this, a primary character interact. And then the last one we have here is enhanced input component, bind, and this will be the toggle inventory action, triggered this, and the toggle inventory. We're going to change the way that we open and close our inventory just a little bit from what we did in the blueprint section. So that's why we've only got one command for that here. And then that's it. We just now binded our input actions to this. Now, of course, this won't work until we change it in blueprints, which we will go back and do towards the end there. But yeah, this is pretty much how you set up all your functions or all your inputs for your player character, any type of character that you have. This is pretty similar if you've ever done this in regular, in the pre 5.0 before enhanced input. This is essentially the same thing that we had to do for the old system as well. So it's just binding all our actions. These are all delegate calls. So let's go ahead and set up the functionality for this. But first, before we set that up, I'm going to come up here to the constructor for the class, and I'm going to make sure that I go B use control rotation yaw is equal to true. This shows our intent in here. We can override it in blueprints if we ever want to go false, but I'm setting it here to true just in case, because that's what we want. And then the last thing we need to set up here is in the begin play under the super, we're going to go set player mapping context. We're going to call that function on begin play, and we're going to give it the input mapping context. That's the variable that we created up at the beginning. So we're going to pass our mapping context in here, and I created a separate variable because we're going to call this several times. If you remember how we did it in blueprints, when we switched to the user interface, we actually remove our player mapping context, add a new one, and so there's a lot of that. So that's why I created a function for that. So now that we have that, now let's go ahead and build our functions. And so move down here and let's work on these. All right, so in the set player mapping context function, let's go ahead and set this up. I'm going to type if const a player controller. It's going to be a pointer. We're going to call it player controller equal to get world, get first player controller. So essentially what we're doing here, right, is we're creating a local variable called player controller. We're getting the world and we're getting the first player controller in the world. Since this is a single player game, we know we're getting the one that we need. So it's get the first player controller. We don't need to cast this. So this is just kind of a quick down and dirty way to get your player controller that is controlling the character or the pawn that we're putting the function in here. We may at some point save the player controller as a variable, but we don't really need to at this point. The reason why we're doing it here is because as soon as this function call is done, it drops that pointer and gives us the memory back. If we put it into a variable, it's going to hold it to us until we destroy that variable, so or the function or whatever, you know, the instance of the object. So once the game essentially is over, then we'll lose that. So this is just a quick, easy way to be able to give us access to the player controller without keeping it into stored in a memory. All right, so we got that. And so if we do have the player controller, right, the reason why we put this is in an if is because if it doesn't exist, we don't want to run this functionality. So that's why we put this in the if, right? We could have put this on the outside and then checked if player controller, but it just it makes it a little bit more understandable of what you're trying to intend there, because we're not going to call this outside of the if. So we call another if u enhanced input local player subsystem. This is the header file that we included earlier. If you didn't include that subsystem header file earlier, then you will probably not see that there, and you'll have to include it for this to work. So subsystem is what I'm going to call it, and it's going to be equal to u local player, and we're going to call the function get subsystem u enhanced input local player subsystem, and then in the parentheses we're going to go player controller, and then we're going to go get local player. Make sure you close it out with the brackets, and then open up the brackets here because it's an if statement. So now we need to run the if, close that so you can see all of it in a single line. So if we have the u enhanced local player subsystem, we're calling it subsystem here. It's going to be a u local player, which is an object function. It's a static function call called get subsystem, and it's going to be in the class u enhanced input player subsystem. And we're passing in the player controller, and we're getting the local player. So now we're getting the character that is controlled by this player character, which is itself, but this is what you have to do in order to get the actual subsystem. We can't just pass this into here. With that in hand now we can go subsystem, add mapping context, and the mapping context we want to pass in is what we're passing here. So we'll go mapping context, which is this right here that we're passing in from the begin play where we're calling it at. And to finish this off, we have to go comma 0, which 0 is its priority. So we want it at the lowest priority. 0 is actually the highest priority, but so we're going to include that there. You can put that any number you want. Close that out with semicolon, and there we go. Our player mapping context is complete. So now before we move on to the move function here. Let me go ahead and open up the editor and show you exactly what we're doing and how we're going to move this functionality over. All right, back here in the player controller where we currently have our move functionality. I'm going to zoom in here so you can kind of see what's going on. So in our player move, we got the triggered here. Remember, this is what I was talking about earlier when we set the bindings here. So we got triggered. So while it's being triggered, it's coming into this function here to add player input movement. And the scale value, it's taking in two parameters, taking a world direction and a scale value. We can set this. This is going to be default anyway, so we don't have to set this one way or the other. But the two we're passing in is world direction and scale value. And the scale value that's coming in here is the action value X. What we're passing out of this move is actually a vector 2D. If I disconnect these and close these pins up, it's going to be a two-dimensional vector. We just split it apart. So we take the X, we're passing it into this first one here, which is the right vector direction. And then we're taking the Y, we're passing it into another input movement, which takes in the world direction, which is our forward vector. And then it's adding the scale value of our Y move 2D vector. All right. So when you're running this, when you're running functions, let me kind of minimize this down a little bit here. So when you're trying to move your functions from blueprints into C++, look along the chain of execution. We have all these functions here, right? We got get control rotation, make rotator, get right vector, get forward vector. But these aren't part of the execution path. They're being called as part of this. These are what we're getting the arguments for these function calls, okay? So this is what you want to do. So let's go like this. Let's start. I normally wouldn't necessarily start this way, but this is how you should really think about this. So we're in the move function, right? So with that, I'm going to add two add movement input functions because we got one and we got two. So I'm first going to go create a variable here. I'm just going to call const f vector 2D. We're going to make it f vector 2D. I'm going to call this one movement vector, and this is going to equal the value that we're passing in dot get f vector 2D. Okay, so I'm just setting this here first. We're taking the value that we're passing in because right now this is a template function that's being passed in here. What's being passed in is a float, but we have to now take these float values. It's actually a 2D vector of x and y, which are floats. So, but we have to take this value being passed in. We want to throw it into the vector 2D. We're calling it movement vector, but we're just getting these values. We're getting the f vector 2D from this value here and storing it into this variable. Okay. What we need to do is we need to do an if controller. Now you're going to ask, where did this controller come from? I'll show you in just a second. Null pointer. Okay. So this controller is a base function within the pawn class. So by hovering over it, you can kind of get a little bit of information, but you can see at the bottom it says pawn.h. This is just, the controller is a variable within the pawn class. So we have access to it. So we're just making sure we don't care if it's a player controller. We don't care if it's an AI controller. This pawn doesn't have a controller. So controller is not equal to null. So in order to run this, we have to make sure that there's something in this controller, and way back in the pawn class, this is being set if there's a controller there. So we're just ensuring that it has a controller. All right. So from here, now we can add our functionality. So we have add movement input. And then in here, the first one, I'm going to go, when you looked at that, we were passing in the right vector and the forward vector. So I'm going to type this as right direction, comma, and now we're going to take our variable, our local variable that we created, movement vector dot X, and then I'm going to add another one, add movement input forward direction movement vector dot Y. So you're going to see they're red here, but now we need to define it. But this is the course of the flow of functionality here, right? So if I bring back the function from blueprints, we got add movement input, right vector. So I'm calling this right direction. You can call this right vector if you want to. We're going to define this in a minute, and these will no longer be red. But we got the first add input. We're passing in right direction like it is here, and then we're passing in the scale value, which is the movement vector dot X. Movement vector is being what's passed in here. We're passing the X to that. So now we need to define the right direction and the forward direction. Well, and you can see with that, we got get control rotation. We're taking the value Z, which is the yaw. We're making a rotator out of it. and passing that and getting the right vector and the forward vector. It's a little bit different. For the most part, you can follow it like this, almost one-to-one from blueprints into C++. With this, it's when it comes to rotators though, they're a little bit different. Rotators a little bit complex, whether blueprints or in C++ to work with, but it's not that bad. I'll explain as we move along. So let me get this out of the way, create a little bit of space here. So what we have now is I'm going to create a new local variable. It's going to be a const f rotator. I'm going to call this rotation, and we're going to set it to the controller, which is the pawn controller like we described in the if statement. And then from the controller, we're going to call the function get control rotation. So we're calling the controller like we did here, calling the function get control rotation. We're setting it here into the rotation variable. Next, I'm going to go const another f rotator. I'm going to call this one yaw rotation. Rotations are a little bit different. You don't always have to do equal when you're doing it. When you're just setting the values of the rotator, we can just put this in parentheses, go 0. And for the yaw, we want to go rotation dot yaw. Okay, so we're calling the yaw value from the rotation variable that we just set. And then for the roll, we're giving it a 0. So we're passing in the pitch 0, yaw from the rotation, and then 0 on the roll. Okay, so now with that information in hand, we can go const. Now we need to set the vectors, right? Because we're passing in the vectors, right? So what we did here is now we just pass the yaw in. We get the control rotation, get control rotation. We're grabbing the yaw out of that, which happens to be the middle. Here it shows it in the third slot, but when you hover over the rotator, you can see that the yaw is actually in the middle. So we're saving the yaw to the yaw rotations. Now we have this, right? So we just made a new rotator there, which is the yaw, what we're calling yaw rotation. Okay, so now we need to turn this into vectors so that we can pass it into the add movement inputs. So now we take a const f vector, and we'll call this one right direction, and it's going to equal f rotation matrix, and in parentheses we're going to pass in the yaw rotation dot get unit axis. Make sure you do axis, not axes, axis, and then in here we will give it e axis, and this is a static variable, so that's hence the 2 colons there, and we're going to pass in y. Generally what we're doing here, the matrix, it does more, it takes the dot product, normalizes everything. It's a function in here. So when it runs this and calls this array, and we get the get unit access in here, it's getting the normalized value from the dot product of your direction. So essentially it's taken the character, and in the yaw position, which is in the 360 position, if you're looking straight out from the character, in the yaw position, it's just getting that direction and getting the unit axis, which in this case would be the y. Then we're going to do another one, f vector. We're going to call this one forward direction equals f rotation matrix, yaw rotation, get unit, not on my game there, f rotation matrix, get unit axis, e axis x. And there we go. I know it's a little bit confusing. Rotators are relatively confusing, and I'm sorry I can't give you a better explanation of exactly what's going on in there. You can do a little bit of search for the F rotation matrix, and you might be able to find a better explanation. But generally, it's just doing some math behind the counters for us, and it's just getting the values of which way we're facing it. It's essentially what the get forward vector and get right vector functions are doing for us in blueprints. This is that code right there. Okay, so now we've got these. You can see these went away. So, and that's it. That's how we translated our blueprint code into C++. Now, like I said, it's not as obvious given the F rotation matrix and all that, but the process is the same. We add the functionality, we define the arguments for that, and we gather the information for that argument. So that's how that works. So let's go ahead and move on to the look. This one is a little bit easier to do, but pretty close to the same. So we're going to go const f vector 2D. We're going to call this look axis vector, and we're going to go value, which is the value that we're passing in, get f vector 2D, and there we go. So now we got our look axis vector. We're going to go if controller is not equal to null pointer. Let me bring over the blueprints here, and in here let's take a look and see what we're doing. So we've got the triggered event. When it's triggered, it's coming in, it's adding yaw input, and then it's adding pitch input. So for the yaw, we're giving it the X value of the vector 2D. we're getting the X and we're passing it into yaw. Then we're taking the Y value and we're passing it into the pitch input. So now inside the if we go add controller yaw input, we're gonna give it, pass in look access vector dot, and we said for this X, right? So that's what we were passing in blueprints. Now go add controller pitch input, and again, look access vector dot Y, and there we go. There's our look functionality all set up. So now we're not going to do anything for interact or toggle event at this time. And jump is set because we've got a super function here that is being called by jump. If there's other things you want to do in jump, which we may end up having down the road, then you add stuff here, because there's oftentimes some things you may or may not want to do during a jump animation or jump sequence in there. And that should be it for the C++. So I'm going to go ahead and close down my editor really quick. Once it's done, I can build it. I'm just going to hit play here. It's going to build it before it plays it, but I want to go ahead and play the editor. I want to relaunch the editor. And for me, I ended up getting this error. I did my testing one. I'm not quite sure why this happened. It happened to me in my test one as well. I come up here, it tells me where the error is at, primary character.h1. This probably isn't going to happen to you. Most likely it's not going to happen to you, but if it does, this is what happened. You see here, for some reason, I didn't type this in. You guys watch me do this. It automatically put the include here for itself, right? This file I'm in is the primary character.h. It added itself here, and it's seeing a circular dependency. So that's the issue there. So I don't know why that happened. Like I said, it happened to me in my testing leading into this video. So I just delete that. So now if I hit play again, it should just build it just fine. All right, so now we're back in here into the player controller for the first true first-person character. And I'm just gonna go ahead, I'm not gonna delete all this yet. I just wanna make sure everything's working. I'm gonna remove the execution though. So none of this is being called. I'm going to do this for all three of these functions here, including on the complete there for that one. And then I'm also going to come down here into the begin play in the player controller. This is where we're setting the mapping context. We want to remove this execution as well, because we want to, we're setting this inside the C++ class. So this will all end up getting deleted in a short minute. We just want to make sure that it works before we delete all the code. So now let's go ahead and head on over to the player character. And before we set our input actions here, let's make sure that our input is stopped. At this point, we should not be able to move or look around or jump or anything like that. So I'm going to hit play. And then in here, once I select the screen, I should not be able to move, jump, or anything. Yep, I can't do anything within the scope of the game. So I'm going to exit out of that now. So perfect. That's what we expect at this point. So now within the player character blueprint class, since we gave our input actions a category, I'm going to come over here into the details, make sure you're in the class defaults here, and I'm going to search for character, and there we go. We have our category called character input, and then we gave it the subcategory of character movement. So I'm going to open that. Now you can see our input actions right here. So you should already have these set up because we are transferring this from Blueprint down into C++. So you should have these. If you don't, well, go through and add your input actions. I'm going to find our jump action. It's right there. I'm going to do that for all of these, and I'm going to stop there. I'm not going to add the interact action or the toggle inventory action yet, even though we may have these already. We didn't set up these in C++ yet, so I'm not going to do those ones yet. For now though, I'm just going to go look action, move action, and jump action. And then now we need to come down here, and I see that we didn't add a U property to our mapping context. So let's jump back into C++ really quick. Here we need to give our input mapping context. It's in our primary character.h header file. We need to give it a U property. I'm going to give this one a little bit different of a U property. I'm going to go U property, edit anywhere, blueprint read only, category equals character input pipe character movement, and then we're going to give it the meta as well. Meta equals allow private access. So now when we compile this, we should see this in our blueprints. If for some reason after building this again from C++, if you don't see it in blueprints, then you'll have to stop the editor and relaunch it. But I think we should see this just fine. And there we go. I didn't have to reload my editor. We have it, input mapping context. So now let's go ahead and select the one we want. Mine is called I am player, and that should be it. Go ahead and compile it. And now if we hit play, I can look around, I can move around, and I can jump. So there we go. We have that all set up. That's how you set up your input actions for your player character in C++. And I think that's going to do it for today's video. I hope you guys found this useful. Hopefully you get a little bit of information out there. If you did, please do me a favor. Go down and hit that like button. If you're new to the channel, subscribe while you're down there liking it. Hit that bell notification if you want to be updated whenever we drop a new video. And again, thanks for joining me. Until the next one, peace.